Hello Mr Price, and this is the fourth video of the June 2006 N2 paper, and this one is on question 4, all about energies and powers again. So let's have a look. We have a car of mass 900 kilograms travelling at constant speed, implying that it's in equilibrium on a level road. Okay, level road, so there's no working against gravity at this stage. And the total resistance of motion is 450 newtons, and we want to calculate the power output of the car's engine. Okay, as always, a force diagram is going to be extremely useful here. So let's just draw this. Now we know that the velocity is 30 meters per second, and the acceleration is 0, so this is in equilibrium. There will be a force, the driving force of the car, and we're told the resistance to motion is 450 newtons. And we want to find the power of the car's engine. So we know that power is force times velocity. And we know that for this to work, the power output of the car must be 450 newtons, as it's in equilibrium. So the power is 450, and note this is the driving force of the car, not necessarily the resistance. It's just because it's in equilibrium, so it's got to be equal. 450 multiplied by 30, so this gives us a power output of 13500 watts. Okay, that's part I. For part 2, we are told that the roof box is added. Sorry, where is it? A roof box of 50 kilograms is mounted on the car, and our total resistance of motion is increasing to 500 newtons, and our car continues to work at the same rate, so its power remains the same. And we want to calculate the new maximum speed of the car on this level road. So a new force diagram is going to help us here. So our mass is now 950 kilograms. There's going to be a force here, and resistance to motion 500 newtons. Now, to find out the maximum velocity of this car, it's going to be when acceleration is 0, so our car is still producing 500 newtons of force here. So now we know the power and the force of the engine. So 135,500 equals 500 lots of the velocity. So our maximum speed of the vehicle here is 27 meters per second. Okay, part 3. So our power output of the car is increasing to 15,000 watts, and our resistance to motion of the car is still 500 newtons. We want to find the instantaneous acceleration of the car on the level road when its speed is 25 meters per second. Okay, so a third force diagram here. Our weight is our mass is 950 kilograms. Our resistance to motion is still 500 newtons. And we want to find the instantaneous acceleration when our speed is 25 meters per second. There's going to be a force here. Okay, and this time there is going to be an acceleration as well. So, we know that our power is 15,000 watts. And using this, we can get the force of the car. So, P equals FV. We know the power, we know the velocity. This gives us a force of 600 newtons. So now we know this. We can clearly see it's out of equilibrium. So the resultant force is 100 newtons to the right. So using F equals ma, we have 100 equals 950 lots of A. So this gives us an instantaneous acceleration of 9.5 meters per second per second. Okay, and finally, our car now climbs a hill at an angle of 5 degrees to the horizontal, and we want to find the instantaneous retardation, so the negative acceleration of the car when its speed is 26 meters per second. So, our fourth force diagram. Here's our car. It's travelling up a hill, so there's going to be our mg here, so 950g, at an angle of 8 degrees to the vertical. Our resistance to the motion is still 500 newtons, and we need to find our force here. Okay, so our power output hasn't changed, so power is still 15,000 watts, and we know that its speed here is 26 meters per second. So we can find the force yet again, just like we did for part 3, and you should get a force here of 576.923 blah blah blah. Okay, so now we have the force here. We can now once again use resolving forces. So this time it's not quite so simple, so we will do this one properly. So resolving to the right, we have 576.923 minus 500 minus 950 g sine 8 equals ma. Okay, calculating this should give you negative 734.519 equals 950A. So our retardation is 0.773 meters per second, plus or minus. So I suppose it's a negative acceleration, so the retardation is positive. And that is it for question 4.